Hello everyone, my name is Michel Villanueva and I will guide you through the introduction to Docker and Podman as software development tools. This is a page that will be available on the IRIS-HEP software training site. So we will just go through the material and discuss a bit more of about what is already written there. At this point, we expect that you have already followed the setup. The setup is to install either Docker or Podman in your computer or in a computer that you are using in your institution, somewhere that you are allowed to install it. If not, please go to the setup and come back after you have done that. We will start with the introduction. Let me go to this page. And in the introduction, we will discuss what are containers, in particular, what is Docker, what is Podman, and what are the differences. And we will learn the basic concepts on the containerization. So, what is a container? For that, we have some questions for you. Have you ever taken a piece of software from one computer to another and then you found out that this doesn't work anymore? Or had you to install a bunch of dependencies to run a piece of software that was written by a colleague? Or what about saying, okay, this used to work on my machine and then I pass it to someone else, or you install it in a new machine and this is not working anymore. So we often experience that. I think this is a common problem in academia, but also in industry. And the good news is that the industry have provided a solution for this. And the solution is called a container. A container is basically this piece of unit, or this unit of software that contains the software that you are trying to execute, but also all the dependencies. And it's a single isolated unit. Importantly, to say that the container is a lightweight solution. The reason is because when you deploy a container, it uses the kernel of the operating system, not like a virtual machine that has to create a whole environment for itself, but just as this is a, let's say, namespace in which your operating system exists and your process will be executed, but all the low-level commands communicate via are executed via the same kernel as the host. So this is a diagram that is usually shown to explain the differences between what is a virtual machine and what is a container. The container requires a guest operating system that is virtualized. So this is slow down the process. Every time that you want to execute something, it needs to load the whole operating system. And when you have a container engine as Docker, it uses directly the kernel of the host once again, such as you can execute as many containers as needed, and they will all use the same kernel. So it's not isolated operating systems like in the virtual machine. So in many cases, a container is a better solution. There are some other use cases in which a virtual machine will work better. But those are the main differences. And for analysis, I would say most of the time you want to use a container. There is a caveat for this. If you are using Windows or Mac OS, you need one more layer to communicate with the operating system, because the containers usually execute Linux. And if you are using Mac or Windows, you don't have a Linux kernel there. So you need a layer that virtualizes the Linux kernel, and then the engine will communicate with that virtual machine. So for example, if I'm working on Mac OS, and I can say that if I need to install Docker in my machine, it installs something called Docker Desktop that hides a virtual machine in the background to execute the containers, or well, in other words, to provide the Linux kernel to the containers. And I will show you this in a second. And Windows is the same. So if you are using Windows or Mac OS, just follow the instructions on the setup to install the required additional layer. Okay, let's talk about Docker. So this is just the concept of a container in general, and Docker is the most popular containerization tool these days. It's particularly used on industry. It's a platform for developing, shipping, and running applications. And in addition, it also provides a public registry for sharing and collaborating called Docker Hub. I don't know if you have visited Docker Hub once, but if you have visited, but you can take a look, and it just provides many different images from either individuals and institutions. Like for example, I can take a look and search for for images from the Python community, and it provides official images. So this is also part of Docker. It's a whole platform to work with containers, not only the Docker desktop, but also the Docker Hub and so on. There is official documentation that I strongly recommend that you visit if you are using Docker. However, for this tutorial, we will recommend to use Podman, and I would say, or I will explain in a moment why. So first, let's say what is Podman. This is an alternative for Docker. It's another engine for containers. It has one advantage with respect to Docker. To explain, I need to show you how Docker works. So if you go to this link, we put here the documentation on Docker, and in particular how the Docker architecture looks like. So Docker requires a central service, which is the Docker daemon. This is just a machinery that is working in your computer, and any client or any command from Docker that you execute will communicate with this daemon, and the images, the containers as well, are managed by this daemon. This is a central service. What is the problem? Well, the problem is that the daemon by default is executed as super user, as root, and this is a security issue, especially in shared resources, like for example LXPlus at CERN, or the institutional machine that you may be working on right now at the university, at your laboratory. And that's the reason why Docker is usually not allowed to be installed in this kind of large facilities. I'm not saying that Docker is insecure by default at all. I mean, it's widely used in industry. It's just that for certain use cases, or for the use cases that we usually have when we do analysis, it's not the most suitable solution. And in particular, well, you can execute the Docker daemon as non-root. It requires some extra steps, but again, it's always a security concern. If you have a vulnerability in your container, this may be propagated to the daemon and therefore propagated to other parts of the system, because this is just a central service running as root. The difference is that Podman does not make that. It has a different architecture. Every container, it's its own process. It does not require a central daemon being executed in the machine. So it makes it more secure by default. And one more additional reason why we suggest Podman is because Docker has licensing restrictions that may prevent you from using it in some institutions. You have to check if that's your case. Then the Podman is the alternative for you. One more nice feature is that Podman is a drop-in replacement for Docker, so you can use the same commands in any of the two tools and it will work. The only difference is that you have to replace Docker by Podman, or in this particular case, as in the tutorial, we will be using Podman. If you want to use Docker, just replace Podman by Docker and you should be good to go. I need to stress that if you are working on Mac or on Windows, you need this additional layer to virtualize a kernel for the either Podman or Docker engine. This is, for example, how it looks, the Podman desktop in my machine, and it provides a virtual machine that is running on the background. So be sure that you have this desktop running, either Docker desktop or Podman desktop. And this is coming from the setup. Okay, there is one more solution that is called Apptainer. It was formerly known as Singularity, and this is another containerization technology. For now, we will not talk about that. We have a training module that introduces Apptainer and also some differences between Apptainer and Docker/Podman. You can take a look into that later. For now, we will not discuss it, but just to let you know that there is one more available solution. For now, we will just focus on Podman. So that's it for now.